All right, guys, so today we are going to talk about parallel and perpendicular lines on the coordinate plane. So we were looking at lines and angles. We talked about linear equations and graphs on the coordinate plane. And now we're going to take a look at, like I said, parallel, which I usually like to use that symbol for parallel, just because sometimes it's hard to spell. And the upside down T for perpendicular line. We'll do that on 29 and 30. So on page 29, you should have next this one here. So we need to be careful because they all kind of look the same. If you notice, though, this one says parallel and that one says parallel. This one says perpendicular, that one says perpendicular. So we actually want to cut this in half. Oh my gosh, did I lose my scissors? No, there. Too much stuff on my desk. This way. Long ways again. And then that other one we can just recycle. Use as some scrap paper. Okay, so this one we can fold that in half now, like a book. And that's going to go on page 29. Here. And then on page 30, we actually have the next one as well. So I think you're looking at this one. If we flip it over, we're going to fold each short edge in to the middle like this. So you can still see writing equations. So cute. And then if you want to cut out two little doors, you could do that. And that's going on 30. So again, with parallel and perpendicular lines, you probably talked about that last year in Algebra 1 as well. And the big thing to notice about parallel lines, so let's actually start over here, is that whenever we have parallel lines, that's really just code for these two lines have the same slope but different y-intercepts. So that is our big note here. Same slope, different y-intercept. That is a big deal when it comes to parallel lines. Okay? When it comes to perpendicular lines, I just want to make that one a little bit. I can't do it. When it comes to perpendicular lines, there's a similar thing that we need to consider about the slope and the y-intercept. And perpendicular lines don't have the same slope, but they do have related slopes. And their slopes are opposite reciprocals of each other. So slopes are opposite and reciprocals of each other. And y-intercepts are likely different, but they could be the same. Could be the same. We'll say that. Could be the same. Really only when they cross each other on the y-axis. Every other time they're different. But I mean, they could be the same. So just as a reminder, what it means to be opposite reciprocal is opposite means different signs. Reciprocal means flipped. So for example, if I had 2/5, the opposite reciprocal of that is negative 5/2. So you have to change the sign and flip the fraction, both. And that's important because we might want to write an equation or we might want a graph, and that just depends. And this type is so small on here, guys, I'm so sorry, but let's look at this one first. So if we're going to write an equation of a parallel line, write the equation of a line passing through the point, -1, 1, that is parallel to the line y equals 2x minus 3. So what you have to understand is this is a line that already exists. You're trying to write the equation of a new line that is somewhere else, has a different y-intercept, but the same slope. So since my line has the same slope as this line, I know that my slope is 2. I also know that my line has to go through this point, negative 1, 1. So I would put it in point slope form. We have our slope is 2. We have our point is negative 1, 1. So I can put my equation in point slope form, which was that y minus y, which is 1, equals m parenthesis x minus x, which is negative 1, so it becomes a plus. Now, if we want, we could change that to slope-intercept form, and maybe I want to because it's a little bit easier to graph when we are in slope-intercept form. Geez, brain fart. So I would distribute, and we'd have y minus 1 equals 2x plus 2, and then I would add the 1, and so y equals 2x plus 3. And then that's easier for me to graph because I can plot my y-intercept at 1, 2, 3, and then do my slope, which is up 2 over 1. These boxes are so small, this is ridiculous. Anyways, that's my line. This line, let's do this. Let's get some more color in here. This is my line, which is different than the first line, which was at 2x minus 3. So I'd put my y-intercept at negative 3, but I'd still go up 2 over 1. So they are moving in the same direction at the same speed, but they are not in the same place. There we go. Now, if I were to do a perpendicular line, so write the equation of a line passing through the point 2, 3, that is perpendicular to the line y equals negative 2x plus 2. So this is a line that already exists. In fact, I can go graph it right now. So I can plot that 2 on the y-axis and then do my slope of down 2, right 1 because it's still positive, and I get this line right here. So that's the original line that they gave me. I'm trying to write the equation of a new line that is going to be perpendicular to that. So perpendicular just means code for your slopes are opposite reciprocal. Y's could be the same, could be different. So since this slope was negative 2, my slope is going to be positive, and when I flip it to, it becomes 1 over 2, because there's always a 1 under when I flip. So because I have my slope of half and I have a point that I need to go through, so I needed to go through the point 2, 3. I could go graph my line right now because I could plot that point at 2, 3 and then do my slope and have it. But I could also write the equation and then change it to y equals mx plus b by putting it in point slope form. So y minus the y value, which is 3, equals half parenthesis x minus the x value, which is 2. Now this is a perfectly fine answer, but sometimes we do want it in slope-intercept form. So we can distribute, and we have y minus 3 equals half x minus 1, because half of 2 is 1, and then add the 3, and we have y equals half x plus 2, and then I can go graph that line. So this line, my line that I had to find, I need to plot it at 2. Oh, look at that. They do have the y-intercept the same. They don't have to, but they do. And then I go up 1 over 2 to the right. And so I get this line here, which again, remember when we are perpendicular, we make a 90-degree angle on all 4 spots. which that sure looks like it. Okay, let's take a look at this other side over here. That was so small. I'm so sorry if you're having a hard time seeing. Let's see what we got. What do we got? Oh yeah, so I think I'm gonna try 2 more and then leave the last 2 for us to try in class. So I'm gonna do 1 and 2. So write an equation in slope-intercept form. Okay, so they want it to be y equals mx plus b for a line that passes through the point 6, 2. So here is my point and is parallel to this line here, which is just code for slopes the same. So my slope is still negative 2/3. And then we want to graph both lines. So right now I can actually graph the line that they gave me because I have all that info. And so I would plot my y-intercept at 1, and I would do my slope of down 2, and then right 3, because only one number can be negative. And we have this line here. Now we are trying to be parallel to that, so we want our line to go in the same direction. I'm actually going to do this one in a slightly different way, because I really have all the information I need right now to graph the line, because they want me to go through this point 6, 2. So I could plot that 1, 2, 3, 4, 5, 6, 1, 2. And then I need to be parallel to that, so I need to do the same slope. So down 2, right 3. And so then I get this line right here. So I can actually draw this line right now, which is kind of nice because then maybe I can see where my y-intercept is as long as I draw my line real straight. So it seems like my y-intercept is at 1, 2, 3, 4, 6. It seems like it might be 6. I'm going to do the math just to be safe. So I'm going to put it in point slope form. Y minus 2 equals negative 2/3, parenthesis x minus 6, and then distribute. So y minus 2 equals negative 2/3 x, and then plus. So I always divide first, like 3 goes into 6 2 times, and then 2 times 2 is 4. And then add the 2 over. Oh my goodness, look at that. It is at 6. Fun. So as long as we draw a real nice straight line, or if we count out that slope more, oh, I could have done that. Let's try that on the next one. All right, looking at example 2. Oops, so that's that line. Example 2, we want to write an equation in slope-intercept form. So again, y equals mx plus b. That's going to be our final answer. For a line parallel to, wait, I'm going to skip that one. Let's do perpendicular to. Let's do number 3. Write an equation in slope-intercept form, y equals mx plus b. For a line perpendicular to this line here, so perpendicular to that line there is just code for your slope's kind of like that one, except opposite, so positive, and reciprocal, so 1/3, and contains the point 6, 0. So that's our point right there. So graph both lines. Well, I can graph the line that they've already given me right now. So if I graph that line, we're going to plot our y-intercept of 2, and then do our slope of down 3, right 1. It can always be over 1. And you can count that out multiple times. Down 3, right 1. That's what I was kind of saying with the last one. That's a good way to find your y-intercept exactly if you like doing this stuff off of a graph. So kind of like that last one, again, a way to do this rather than maybe algebraically, maybe do it a little bit graphically, is I could plot my point because my line has to contain the point 6, 0. So 1, 2, 3, 4, 5, 6, 0 right there. And then it has to have this slope. So not the same slope, but opposite reciprocal slope. So I'm going to go up 1, right 3. Now that's not really getting me closer to my y-intercept. So instead of going up 1, right 3, I could go down 1, back 3, because double negatives will get you a positive as well. Now again, the reason I'm doing this is because then I can find exactly where it's going to cross the y-axis. So down 1, back 3. Oh my word, look at that. It crosses right at -2. So then I don't necessarily have to do all of the algebra to figure out that my y equals mx plus b has to be this slope of 1/3, and then this y-intercept that I found by counting, which is at -2, so -2. Oh, that's kind of fun. I don't know. I'm a very visual person and I like to count, so that was kind of fun for me. But if you're more of an algebraic type person, then maybe this is the way for you. But both ways are good, and we'll try the other two together tomorrow.